Hello students, welcome back for one more session on types of sets. As we continue the study on set theory, let us try to recall what all discussions we had before. We understood what is the definition of a set. We saw some of the types of sets, that is null set, singleton set, finite set, infinite set. We also came through the representation of sets, that is by roster method and set builder method. Now let us continue the discussion of types of sets with subset and superset. So let us have a look at what is a subset, or what is the definition of subset, what is the meaning of that. So if there is a set called A and it becomes a subset of another set B if every element of A is also an element of B. Let us try to understand how to write it. There is a C-shaped symbol here. Please concentrate on the symbol here. Let me highlight this C-shaped symbol. This symbol is used for subset of, or it is also read as contained in. Very commonly we use that subset of. Okay. In other words, we can write it as C, A subset of B. We can call this whenever A, small a is the element which is present in A. So we can say A belongs to A, then A also belongs to B. The meaning of this is, if you take any element from A, then the same element should also be there in B. Then we can say A is a subset of B. Or the reverse form of the same thing is, B is called the superset of A. Look at the symbol for superset. It is the reverse of subset. For subset is C-shaped and this is inverted C-shaped, right? The reverse C-shaped. That is the symbol for superset of, or we can also read it as contains. So how do we read it? B contains A, or A is contained in B. We can read it as A is a subset of B, or we can say B is a superset of A. When can we say this? When every element in A should also be an element in B. So we can conveniently use this symbol called as implies. See this arrow symbol? This is called as implies symbol. So using this implies symbol, we can define the same definition once more. This is how mathematically we use symbols and define the subsets. A is a subset of B if small a. What is small a? It is an element. Okay, an element which belongs to A implies the same element also belongs to B. Okay, how do we read it? A is a subset of B if A belongs to A implies A also belongs to B. Or we can say that B is a superset of A. Let us see some examples for a better understanding. If A is a set containing 1, 2, 3, B is a set containing 1, 2, 3, 4, and C is a set containing 1, 2, 3, 4, 5, 6. Okay. So have a look at the sets and their elements. First, A can be called as a subset of B. See the symbol here, C-shaped means subset. A subset of B. Or in the reverse way we can say B is a superset of A. Why can we say A is a subset of B now? See, let us not study both of them together because that is a little confusing. Let us go with subset first. Once you understand, we can go through the video once more and try to identify the supersets. Now, A is a subset of B, means A is a part of B. A is hidden inside B. See, look at B. B contains 1, 2, 3, 4. But 1, 2, 3, what are they? 1, 2, 3 is nothing but set A. So, A is contained inside B. We will find A inside B. There may be extra elements in B. That doesn't concern us. We are only looking at one condition. What is that? Whether all the elements of A, that is 1. Is 1 found in B? Yes. Look at 2. Is 2 found in B? Yes. 3. Is it found in B? Yes. So all the elements of A are also the elements of B. That is enough for us to say that A is a subset of B. You may ask, sir, what about this 4? Yeah, 4 is in B but not in A. So B is not a subset of A. right? A is a subset of B. Clear? Now let's go for a connection between A and C. Let us compare these two. A contains 1, 2, 3. Check. C also contains 1, 2, 3. But C of course has more elements. We are not concerned with that. We can say A is a subset of C. Why? Because every element of A is also present in C. What about B and C? Let's compare between B and C. Okay. B contains 1, 2, 3, 4. These are the elements. Do you find the same elements in C? 1, 2, 3, 4. Yes, of course. That means B is a subset of C. Now let us see whether in the opposite direction can we find the subsets. Okay. B not a subset of A. See, we are saying B is not a subset of A. Why is not a subset? See, 1, is it there in A? Yes. 2 is there in B. Is there in A? Yes. 3 is present in B. Do you find 3 in A? Yes. What about 4? 4 is there in B, but not in A. So, because 4 belongs to B, but 4 does not belong to A, we can say B is not a set of A, is not a subset. See, the subset symbol with the striked out symbol is called as not a subset. This is read as not a subset. Just have a look at subset, not a subset. And similarly, the reverse way of saying that is A is not a superset of B. Whereas we had said B is a superset of A is not a superset of B. See, to say that it is a subset, look at the reason. Because every element in A is also in B, we said. Concentrate on this, every element. But to say it is not a subset, we just needed one element. Look at that, 4. Only one element enough. Okay. Let's go to compare with C and A now in the reverse order. Comparing whether C is a subset of A. C contains 1. Yes, it is there in A. C contains 2. Yes, that is there in A. C contains 3. Yes, that is also there in A. C contains 4. That is not there in A. Enough. That one number is enough for us. If you want, you can continue, but 1 is sufficient. Any one number. That is 4. 4 is there in C, but 4 is not present in A. That is enough for us to say that C is not a subset of A. If you want, you can compare with 5 also and 6 also. So here, look at the reason. Because 4, 5, 6 belongs to C, but 4, 5, 6 do not belong to A. So the first set mentioned in this sentence is not a subset of the second set. That is C, not a subset of A. Please remember, here I have marked all the 3, 4, 5, 6. Not needed. Any one is sufficient. Any one. Okay. Now let's compare C and B. First I am taking C, then I am taking B. Okay. C contains 1. Yes, it is there in B. C contains 2. That's also there. 3. Yes, of course. 4. Yes, 100% right. But 5. No. 6. No. Any one of them if you take, that's enough to prove that C is not a subset of B. Because 5 and 6 belong to C, but same 5 and 6 do not belong to B. Again I reiterate, don't worry, you don't have to say all the elements, just one of them if you show that. See, first time there is a belongs to symbol, next time there is a not belongs to symbol. That's enough to say C is not a subset of B. Let us have a look at some of the sets which we regularly use in mathematics. These are N stands for natural numbers, W stands for whole numbers, Z stands for integers, Q for rational numbers, IR that is for irrational numbers, R for real numbers. If you have a look at the relation between N and W, see I am taking N natural numbers as the first set, whole numbers as second set. So every element in the first set, that is 1, 2, 3, 4, 5, 6 continues till infinity, is also an element of whole numbers, right? Whole numbers you have an extra 0, but every natural number is also a whole number. So what is the first one I am taking? Natural number. Second I am taking whole number. Since every element of the first set is present in the second set, we can say the first set, that is natural number, is a subset of the second set. Similar argument for natural numbers and integers. Every natural number is also an integer. But there are, of course, extra numbers in integers. That doesn't concern us. So natural number is a subset of integers. Similarly, natural number is contained inside rational number. So you can say natural number is a subset of rational numbers. This natural number is also a part of this big rectangle from outside, that is real numbers. So you can say natural number is a subset of real numbers. But natural number is not a part of irrational numbers. See, any number you take, 1, 2, 3, 4, 5. These do not belong to irrational number. So first set is natural number. Second set is irrational number. Take any number from this. Example 4. 4 belongs to natural number. 4 does not belong to irrational number. So what did I say? If first one is belongs, second one is not belongs to, then immediately you can say that the first set is not a subset of second set. That is what we have written here. Natural number is not a subset of irrational numbers. Let us now compare whole numbers with all the other sets. So whole numbers and z, that is whole numbers is inside integers. Integers is denoted by z. Okay. The first set is w, second set is z, or you can also use I, no problem. So first set w, all the elements in w are also present in z. So you can say safely whole numbers are a subset of integers. Now whole numbers compared to rational numbers, which is bigger than that. Rational numbers, all whole numbers are there present in rational numbers. So whole number is also a subset of rational number. How about whole numbers and this big set real numbers? Yes, of course, all the whole numbers are also found inside real numbers. So whole numbers is a subset of real numbers, but whole numbers is not found inside the irrational number. See, any whole number you take, 0 for example. 0 is a whole number. Yes, it belongs to first one, w. Does it belong to the second one, ir? No, it does not belong. So what can you say? The first set is not a subset of the second set, which is the first one here, w, not a subset of irrational, right? And what about whole numbers and natural numbers? If whole numbers is the first set, natural number is second set, then take one element in first set, 0. That is present in whole numbers? Yes. But is it present in the second one, natural numbers? No. The natural number does not contain 0. So what can you say? Whole numbers is not a subset of n. Of course, it is bigger than n. How can it be a part of it, right? Next, let us compare integers. See, integers should be a subset of things which are bigger than that, right? It cannot be inside its own parts. So, integers is subset of rational number. Integer subset of real number. That's all. So, come here. Z subset of Q, Z subset of R. Only two of them. But the remaining three, one is irrational number. Yes, none of the elements in Z can be found in irrational numbers. So, not a subset. First part is that Z not subset of irrational. Now, how about Z and natural number? Again, Z is bigger, natural number is inside. So, there are a lot of numbers in integers which is not there in natural. I just need one example. Okay, anyone? So, I'll take this minus 4. Minus 4 is in integer, but minus 4 is not there in natural number. What can you say? Not belongs to means Z is not a subset of n. What about whole numbers? The same minus 4 I'll take. It is present in Z, but it is not present in W. How do we mathematically say the same thing? Minus 4 belongs to Z, but minus 4 does not belong to W. So, Z is not a subset of whole numbers. Let us now come for rational numbers, the bigger one. Rational number is contained inside real numbers only. Okay, it is not found inside any other. So, you can say rational number is a subset of R or contained in R, real numbers. But for all the remaining, it is not a subset. See, rational number contains 1 by 2. Is 1 by 2 a part of irrational numbers? No. 1 by 2 is a terminating number. You cannot get a terminating number in irrational number, right? So, one number also, if you find that 1 by 2, it is not there in irrational, it does not belong to irrational. What can you say? We can say that rational number is not a subset of irrational. Q is not a subset of IR. Similarly, how about Q and N? See, Q is bigger. You have, for example, 1 by 2, which is not a part of natural numbers. So, rational number is not a subset of natural number. Same 1 by 2 if I compare with whole numbers. 1 by 2 present in rational numbers or belongs to. 1 by 2 does not belong to whole number. What can you say? Rational number, not a subset of whole number. Here, Q, not subset of W. Last comparison is rational numbers and integers. Same 1 by 2 if I take for rational numbers, yes, belongs to integers. Does not belong to. Integer do not contain fraction. So, what can you say now? We can say that Q is a subset of not a subset of integers, right? Yes. Last, we'll talk about irrational now. Irrational number, as you see, this yellow box is a part of the blue box, right? So, irrational number is contained inside real numbers. Take any irrational number, root 2, root 3, 2 minus root 7 by 5, 1 plus root 5 by 7. All these irrational numbers are a part of real numbers. True? So, irrational number is a subset of real numbers. For all the others, irrational number is not a subset. You can see irrational number not a subset of natural number. Irrational number. Example, I'll take root 2. Root 2 is present in irrational. Is it there in natural? No. So, not a subset of natural numbers. Irrational so, similarly, we can root 2 does not irrational number is not a subset so, root 2 does not any other to W. Subsets. So, any other set not a subset real numbers. Just remember the note that null set is considered as the subset of all sets. See, no matter what big set or a smaller set you take, always there is empty space or a set of points which do not exist there. For example, if you consider in natural surroundings, let me take something that we can concrete examples, let me take which we can understand. In a room, okay, there are a lot of air particles, right? Yes, so we can say there's carbon, there carbon dioxide, there is hydrogen, nitrogen, everything. So room looks empty, but it contains a lot of molecules. Still, there will be empty space between the molecular structure. Between molecules, there is distance. So there is some empty space of vacuum where nothing is found. So it is no matter what room or what a box you take or a building you take or a small particle you take, there is space inside that where there is nothing or like vacuum. We can call that as null or a void. Same like that in any set, if you consider, there is always a presence of emptiness inside. There will be some empty space inside the set, which we can call as null set. So null set becomes a part of all sets. You just remember this, null set is a subset of all the sets. So for practice, I'm putting some questions here. So given below are few sets, compare all possible pairs of sets and write whether they are subsets or not. See here, to say they are subsets, you have to compare all the elements in the first one, whether they are present in the second one. But to say it is not a subset, just take one example, any one example, that will be enough. So these are the sets given here. A 1 2, B 2 3 4, C set of 3 4, D set of 1 3 4, E set of 1 2 3, F set of 2 3 4 5, G set of 1 3 4 5, H set of 1 2 3 4 5, and I, last but not the least, the null set or the empty set. So try to practice comparing two at a time, like A and B you take, A and C, A and D, A and E, A and F, A and G, A and H, A and I. Similarly, the reverse, B and A, C and A, D and A, E and A, F and A, G and A, H and A, I and A. Once you have done with that, now you can start comparing with B and C, B and D, because B and A is already over. You can now start with B and C, B and D, B and E, B and F, B and G, B and H, and B and I, and the reverse process. So as you continue like this, you will get a lot of practice if you compare all of them with each other. So all the best. Thank you.